Consider the simultaneous equation on the board. How can we solve this system of linear equation? By using the matrix inverse approach. Well, the first thing we want to consider doing is to detach the coefficient of those variables from the variables. However, in that process, we need to express it in column form of a matrix. So therefore, we are going to have 2, 5, 3, 8. Keep in mind, the order matters. 2 come first, then put it in, followed by 5, followed by 3, and 8. And that is how to arrange it. Now the next matrix will be consisting of the variable x and y. And this will be equals to the last column matrix, which will consist of the solutions, -1 and -2. Now we have the corresponding column form equation of this system of linear equations. If we expand all this, we would end up with this. Keep that in mind. However, you can try that. So what if I set A to be equals to this matrix 2, 5, 3, 8? Then this expression right here can be written as A multiplied by xy equals -1, -2. Now, what if I determine the inverse of matrix A and then multiply by the both side of this equation? What would we have? Let's see. So I'm going to have A inverse multiplied by A then multiplied by xy to be equals to A inverse multiplied by -1, -2. Keep in mind, let A inverse come first, followed by this. There's a reason for that, so that the product at the end of the day will give you your solution. So you notice that A inverse will cancel out, or it produces the identity matrix as equivalent, and left over will be xy equals A inverse multiplied by -1, -2. If you do this math, at the end of the day, you'll be left over with a 2 by 1 dimension column matrix and have xy to be equals to some number you won't know, that we don't know yet, AB. Now, in matrix, if you have something like this, you can set the element in line with each other to be equal. X can be equals to A, while Y can be equal to B. And whatever value of A and B is a solution. Now, we have been dealing with letters. Let's try to analyze this by making use of numbers. But this is just the basic idea behind using matrix inverse approach to solve simultaneous linear equations. So let's do the problems before us. So our goal is to determine A inverse. So what would be A inverse? A inverse will be 1 divided by its determinant, then multiplied by this matrix. What matrix will it be? That will be 8, 2, -5, -3. So what have I done? All you need to do is to flip the element in the leading diagonal of matrix A and negate the element in the other diagonal. It's something you want to keep in mind. So now, let's determine the determinant of matrix A. That will be the product of the element in the leading diagonal, that's 2 times 8, the minus the product of the element in the other diagonal, that's 3 times 5, which will result in 16 rather, minus 15, and therefore we have 1 as the determinant. So therefore, the inverse will be 1 divided by 1 multiplied by 8 minus 5 minus 3 and 2. And I have 8 minus 5 minus 3 and 2 as the inverse of matrix A. So what I'm going to do next now is to multiply the inverse of this matrix A by the both sides of this equation. And therefore we have 2, 5, 3, 8 multiplied by its inverse, which is this 8, -5, -3 and 2, and multiplied by xy, And this would equal to the inverse 8, -5, -3, and 2, and multiply by -1, -2. So we multiply it by the both sides of this equation. You notice that this cancels out, or they will produce an identity matrix. And left over is just xy equals 8, -5, -3, and 2. This is 2, not -2. Then multiply by -1, -2. So the next goal is to focus on the right hand side. Let's multiply those two matrices. 8 -5, -3, and 2 times -1, -2. To multiply two matrices, just multiply the row by the column and add them up. So that will be 8 times -1 plus -5 times -1, -2. Then for the other operation, that will be -3 times -1 plus 2 times -2. And if we continue this, we will end up with -8 plus 10. Then we have +3 plus -4. So what I did was that -3 times -1 is +3, 8 times -1 is -8, -5 times -2 is +10, and this times this is -4. Perfect. So therefore, we can now have this -8 plus 10 and 3 minus 4, because positive times negative is negative, and that will be +2 and -1. So don't forget, it is y that is equal to that. Finally, we can set x is equal to 2 and y equals -1. You can plug this in the given equation for you to confirm that. 2 times 2 is 4, 5 times -1 is -5. If we add that, we will have -1. So therefore, our solution is right. And this is how to make use of the matrix inverse approach to solve simultaneous linear equation. Example 2. 3x minus 4y equals 1 and 7x plus y equals 3. Consider the simultaneous equation. Pause the video and solve that system of equation by the use of the matrix inverse approach. So first, let's detach the coefficients. Now with 3, -4, 7, and 1. The coefficient of y here is 1. Coefficient of y here is -4. That will be multiplied by xy, and that will be equals to 1 and 23. So the goal is to determine the inverse of this matrix. So I'm going to set it to be equals to b and 1. So what will be the determinant of b? That will be equals to 3 times 1 that's 3 minus 7 times -4, that's -28. And that will eventually result in 3 plus 28, which will be equal to 31. So therefore, the inverse of b equals to 1 over 31, which is the determinant of b, multiplied by the change in elements of the linear diagonal of matrix b, that's 1 and 3, and the negation of the element in the other diagonal. That will be -7 and 4. How? We have negative here already. If we multiply by negative sign again, it becomes positive, while this becomes negative. Now, if we multiply this and expand it, we will have 1 over 31 minus 4 over 31, and we have -7 over 31. This is positive. Keep in mind, 3 over 31. It is positive. Perfect. Now, to our final answer, xy, we said it will be equals to this matrix 1 over 31, 4 over 31, minus 7 over 31, and 3 over 31. And this is multiplying 1 and 23. So let's multiply them. Let's see what would happen. What would be the final answer? 1 over 31, 4 over 31, minus 7 over 31, 3 over 31, and 1 and 23. So 1 over 31 times 1, that's 1 over 31. So we are adding that to 4 over 31 times 23. 4 times 23, that will result in 92 over 31. So we are adding that together. Then for the other one, that will be negative 7 over 31 times 1. That will be negative 7 over 31 plus, we have 3 over 31 times 23. That will result in 69 over 31. Now let's add this up to see what will result in that. So that will be equals to 1 over 31 plus 92 over 31. That will be 93 over 31. And negative 7 over 31 plus 69 over 31. That will result in 62 over 31. And if we simplify this, we will end up with 3 and 2. So therefore, x is equal to 3 and y is equal to 2. And that will be our final solution. Now, if we plug in 3 as x in the equation and 2 as y, we would end up with 1. Why? 3 times 3, 9, minus 4 times 2, that will be minus 8. 9 minus 8, positive 1. And boom, you have your final solution. And that is how to easily and mentally make use of the matrix inverse approach to solve simultaneous linear equation. Hopefully you now know how to do that. Thanks for watching. See you guys in the next video. Bye for now.